So if we start briefly with who Veolia are. Veolia is a global leading environment services company, and we work in specific areas, being waste, water and energy. In the waste side, we look specifically at recycling, and we deal with solid and liquid waste handling. Prevalent to the brewing industry, we have a certified destruction facility up in Sheffield. These guys will destroy cans, bottles, etc. They take the alcohol out of these, they mix it with waste food, actually from the ASDA sites, and this soup is then used to produce biogas through an anaerobic digestion process. On the energy side, we're looking very keenly at renewables, looking specifically at waste to energy sites, and we have solid and liquid anaerobic digestion processes, for example. On the water side, specifically on Veolia Water Technologies, we'll talk more about today, we deal with technologies focusing on recycling and sustainable solutions, and obviously given our business, we are very sensitive to low energy and low waste solutions. So Veolia Water Technologies, as you can see, we have a wide range of solutions, dealing in design and build process water treatment systems, looking to move from borehole water quality to production quality, whether that's in the brewing industry, dairy, soft drinks, food and beverage in general, or whether it's pharmaceutical or in the healthcare industry. We have a laboratory system where we actually have a research and development system here in the UK where we actually build all this equipment as well, whether that's looking at quality control within your factories or, again, as we've already discussed, in hospitals or in healthcare. We have systems to meet your requirements for utility water to help you meet the regulations and also to reduce costs, whether that's with boiler feed, cooling water feed or pasteurisers. We have a process wastewater treatment division. We have a large design and build solutions team based up in Birmingham, and they can deal with full treatment or partial treatment, whether we're just looking to either reduce your costs on the Mogden formula or whether you're looking at full recycling through an MBR process. Here in High Wycombe, we have our service division, and we have 64 engineers on the road at any one time, and we can offer a variety of customised service packages to meet any site's requirements. Through Hydrex, we have our water treatment chemicals business, again focusing on boilers, cooling towers, pasteurisers, anti-scalants for process water treatment. And we also have our mobile water services. Now these are process water or wastewater equipment on the back of containers, so should there be an issue on site, we can get one of these lorries to site within 4 hours, and we can have a guaranteed process continuation. Like I say, whether it's on process to make sure you continue to make beer or milk, or in the pharmaceutical industry, or whether it's in the power industry. So, what are the hygienic design standards that are driving these quality changes? Well, as you can see on the screen there are any number of existing legal requirements and international standards and directives that are being applied to beverage production. We have the Codex, which looks at hygienic practices for each food type, right the way through to the machine directives, and EHEDS, the European Hygiene Engineering Design Group, which look at specifying specific valves and design systems to help make the systems more hygienic. So I think it's very interesting that under the European law, water is only classed as food from the moment it goes into production process as a raw material or the moment it goes into a bottle. And to avoid problems with increasing hygiene legislation, we're continually being asked to look at hygienic design, not only for the water treatment plant, but the entire process. Now, whether that's a filling line or whether it's a washing line, the hygienic design doesn't just stop at a piece of equipment, it's about the entire process. There is no actual specific guideline for water in all of those regulations. There are actually more regulations regarding conveyor belts than there are specifically for water. So it's the job of companies like ours to go through all these regulations and find out exactly what these quality drivers are that are driving the change towards hygienic design. If we look at market trends, and these are really quite important, what's actually trying to drive the effect of the change as well as these legislative requirements? but as was recently discussed at the Camden BRI members' interest groups, chlorates and perchlorates, there is legislation coming through on these now, actually trying to find what the detectable levels that will be allowed within food and beverage going forward. And to actually aid this, there's now been technology developed to actually detect the levels of chlorates and perchlorates within beer. So obviously the use of chlorine in water, whether it's coming from town's mains or whether you're adding chlorine for your cleaning purposes, we're going to start facing real issues right across the food and beverage industry by adding these cleaning chemicals. In terms of sustainability, how can hygienic design help here? Well, the cleaner the system, the less cleaning is required, which means increased availability of the system for production, but also less cleaning equals less chemicals or heat required, which means less energy and less waste. So what we're trying to do is look at systems that not only apply to these market trends, but also to the legislation, so that the system that you get is future-proofed against any pending legislation. We don't want to be installing systems now that in 2 years' time don't meet the legislation and need reviving. We're trying to design systems that meet all these requirements now, and therefore we have a future-proof system for the next 20 years. So, what else is driving these market trends? Well, as we've got there, we've got maintenance. If you break into a system, you of course run the risk of introducing contamination, whether that's through bacterial infection or whether that's through using the wrong sealants, for example, or introducing swarf from pieces of processing. If you introduce contamination, you need to clean. So obviously, increased maintenance means increased cleaning, which means increased cost, which means decreased availability of your system. So we're looking to hygienic design to help reduce the amount of maintenance required, and therefore obviously improve the amount of availability and reduce the OPEX costs of the system going forwards. So clever people than me have trawled through all those legislative requirements, and they've had a look at all the relevant regulations and come up with a list of what would be the demands on a system. Now, this doesn't just apply, obviously, as we've already spoken about, to the specific equipment itself, whether that's a reverse osmosis system or a carbon filter. This is going to be to the delivery system, the pipework, the interconnecting pipework, right the way through. And so we've actually looked at systems that are designed to meet these and to meet any possible future regulation that's coming up. Now, obviously, some of these, like I said, they're interconnecting pipework with a slope. This is obviously so we've got self-draining pipework. So a lot of these are common sense, but obviously a lot of these have actually been legislated for and will be law. So if we have a look at a couple of these in a bit more detail, this is a fairly straightforward example. You can see the example on the left-hand side where the thread doesn't quite meet on the flange there. So when we talk about aseptic, we're talking about bacteriologically free flanges. So EHEG have guidelines as to the exact joining flanges that should be used, and it's very clear on the right-hand side there, the one with a nice tick above it, that if you don't have any gaps for water to sit and stagnate, you reduce the capability of the system to therefore become infected. If you give water the chance to sit anywhere in a low-flow environment, it will find a way, unfortunately, to become bacteriologically unsound. Now, that also applies when we're looking at piping design. So we're talking about avoidance of dead legs. Fairly straightforward, really. What we're talking about here is, A, the limit of cleanability, but also that the flow through the system prevents any stagnation of water. If the water keeps moving, doesn't have the chance to sit still, doesn't have the chance to become bacteriologically unviable. Now, that also, again, as we've already spoken about, this isn't just on the pieces of equipment, this is on the interconnecting pipework and your pipework that delivers the water to where you need it within your factory. Again, very, very straightforward, and something that people wouldn't necessarily think about. If you have turbulent flow through your pipe system, what you're doing is you're basically designing the flow to help keep the system clean. That's having a scouring effect across the pipework and is preventing the build-up of bacteria. So again, it's how do we help the design of the system keep the system cleaner for longer? Well, welding finishes. As you can see on the left-hand side, we've done our very best to find the very worst weld possible. But as you can see, on the outside of pipework, throughout any food factory, for example, you're going to find some very, very good quality welds and great finishes. But it's on the inside that the problem is, as we've already discussed. If you give bacteria a place to sit and breed, it's going to sit and breed, and it's going to cause problems. A, because you're going to get contamination in your system, but B, as that bacteria starts to breed and sits there, it also starts to produce some acid, and that's actually going to attack the weld as well. So it's not just about the keeping the system clean, it's also about the longevity of your system by the proper design of the system. So I think we've touched on this a number of occasions through here. Hygiene design isn't specifically about one piece of equipment. It's about looking at hygienic design as a holistic approach. So it's working with a company who understands where all these legislative changes are coming from, who understand where these market trends are. It's selecting the right components, whether these are EH guideline valves, for example, or flanges that we've already discussed. It's about understanding how the design comes in terms of self-draining, in terms of dead legs, but it's then what happens once the system's installed. If you have a hygienic system, we've gone through the monitoring and the assurance of that system. If your operators don't know how to run the system properly, it will not stay hygienic. It's not about what happens on day one, it's what happens throughout the run of your factory. And then obviously competent service. It's about having people who understand how to service your equipment. By servicing it properly, we're ensuring that we're not getting the introduction of bacteria through that service process. We're not using the wrong sealants. We're not taking any opportunity here to keep the system as bacteriologically sound as possible. I'll now hand over to Ralph from Greene King, who's going to walk you through the recent case study.
Good morning. I'm the Engineering Project Manager at Greene King. To give you a little bit of background to this project and the involvement with Veolia. Some 18 months ago, Greene King recognised that there was some environmental savings and, of course, cost savings to move to importing high-gravity beer. Just to clarify, one of the things we do is we have quite a large keg plant, and we tanker in third-party beers, which we keg on our own plant for distribution through our own pub network. Obviously, there's a large cost in tankering the beer in, and by bringing in at high gravity, we will see reduced tankers. So some of those beers will come into us, and high gravity means it's going to be trimmed by 50% with liquor or water. When the project kicked off, everyone was excited about the accuracy of actually trimming the beer down to the correct specification. But as we progressed and looked at this project further and further, we realised actually the water was a really important part. Everyone had focused on the beer, and it's all about the beer, but actually if you're trimming by 50%, the water is 50% of your product. So we had to pay as much attention, in our view, to the water as to the beer pipes. The whole project went out to tender to 4 major suppliers, turnkey suppliers actually, and well known within the brewing industry. Unusually for the brewing industry, we also invited Veolia, who'd shown a great deal of interest in this project, to come along. We were pleasantly surprised with what we found from Veolia. We have got RO plants and filters that are 25 years old, that are from Berkefeld, part of the Veolia group, which is why they got involved. But it soon became apparent once we went to Germany and looked at the Berkefeld PurBev range of equipment that everything Steve has said in this presentation today just sort of hit me between the eyes, that the attention to detail of designing to hygienic standards. It's something that last 15 years in the food and drinks industry I've looked at, whether it's pasteurising, sauces, cooking. They're all the standards we look for as the basics. But then we go and buy RO plants, iron filters that are old carbon steel, plastic pipes, dead legs. And the more I thought about it, the more it just doesn't make sense. So really impressed with this equipment. It's not on site yet. It actually comes in January. But I think it's going to lift our standard of water on site to a completely new level. There's some very tight KPIs around the performance of the water. So we'll be keeping on top of that, and I'm sure Veolia will be working with us to monitor that, because hopefully this is sort of a flagship install for them. The other thing that put Veolia ahead for the project really was their attention to detail, not just on the equipment design, but on breaking down what OPEX costs are going to be on it. The performance of the equipment outperforms everyone else. We're specifically looking at RO plants, carbon filters, etc. So they were very comprehensive with how it needs to be serviced, when it's going to be needed for service, and what the annual cost of running this equipment is. It's something I've put out to other water machine equipment suppliers, and they couldn't come back with even half the detail that Veolia could nail for the ownership of this equipment. So it made it a safe bet for us, in our view, to partner up with Veolia on this. I haven't really got anything else. Any questions at the end, please forward them to Steve, as he said previously, and I'm sure I can answer them for you. And I'll pass you back to Steve.
Okay, thanks very much indeed. So if we just have a quick summary then of what the advantages of a hygienic system are. And as we've discussed, it is a hygienic system. It's not just about an individual piece of equipment. If you improve your water quality, you improve your product quality, and you improve product safety. More and more you see every day in the press that there's been product recalls and there's been issues. The more we can minimise any of these issues, the safer you are as a company and the safer you're going to be as a brand. So by designing systems that need less maintenance, less cleaning, obviously what we're looking at overall is systems that will be, in terms of chemical use, water use, energy savings. You're going to improve on your OPEX. But overall, it's helping you with sustainability, which is a big issue for all our companies, but it's giving you the maximum system availability because you're reducing the cleaning cycles of the system, you're improving the hygiene standards, and you're setting the benchmark for the future. So what is the PurBev series? Well, these are basically tailored to suit the specific site requirements. Now, whether that's heat sanitization or chemical CIP, what the materials of constructions are, or whether it's designed to meet any hydraulic specification. These aren't a bunch of products that are just sat on the shelf and we're going to try to fit you into the nearest one. This is an understanding of what those regulations are, understanding what the needs are to meet the hygienic specification, but then also understanding everything else that's around that. So once we know what your needs are, once we know what your requirements are, whether that's plastic up front of your equipment and then stainless steel afterwards, whether it's stainless steel right the way through because you want complete heat sanitization as opposed to chemicals, especially given the upcoming legislation on chlorates, as we've discussed. These are basically suitable to meet your requirements as a group, as also as international companies. As we've looked at, we ourselves are an international company, and so you can install systems that aren't just going to meet the requirements here in the UK, but will be able to meet the requirements through all your factories throughout Europe and through the rest of the world. So just to sum up really, on the PurBev range, what we have is a complete series of water treatment process equipment, whether that's carbon filtration, media filtration, as it said there, ultrafiltration and reverse osmosis. So please get in contact if you've got any questions either regarding today's webinar or on the PurBev range or any other process equipment requirements, and we'll be happy to answer any questions. So thank you very much indeed for your attention.